Hello guys, welcome back to this new video in my YouTube channel. So basically in today's video we are going to be solving the first question on June 2025 math mechanics. That's the first question that came in that paper. So I decided that I will be solving all those questions, that's from question 1 to question 8, and each video I will make will release one question. So today we are going to be solving this question, and in our next video we're going to be solving question 2. So without wasting much of your time, let us just get started. The question read: the position vector of a particle P of mass 3 kg at time t seconds is given by R equals to t plus sine 2t I plus cos 2t g meters. Find when t equals pi on 4 A the acceleration of P, B the magnitude of the force acting on P, then C the magnitude of the momentum of the particle. Paragraph. Another particle Q is moving with velocity v equals to minus I plus 2j meter per second in the same direction as P. D. Find the velocity of P relative to Q when t equals to pi on 4. Okay, so guys, that was just all about the question, and as usual, we are going to be explaining as we proceed. So the first question we have to look for the acceleration of P. We know very well that acceleration is a derivative of the velocity. That's why I wrote acceleration is equals to dv dt, that's with respect to time. And the velocity is actually equals to the derivative of the displacement as the first derivative of the displacement with respect to time. See, it will simply means that acceleration is the second derivative of the displacement. So if you need acceleration, you have to differentiate the displacement twice with respect to time. So the first derivative, that's the arrow on the t, will simply be d of t plus sine 2t I plus cos 2t j, because arrow was given in two components, so that's the I and the j component from our question above. So if we differentiate the I component, we're going to have 1 plus 2 cos 2t, because if we differentiate t with respect to time, we're going to have 1. And we differentiate sine 2t, we have 2 cos 2t. Remember you multiply the function with the derivative of the angle. When you differentiate 2t, you have 2. And when you differentiate now sine, you have cos. So that's why you have cos 2t in the I component. Then for the j component, when you differentiate 2t, you have 2. Here this is 2 here. Now when you differentiate cos, you have minus sine. So that's why you have minus 2 sine 2t j. Okay. So remember the arrow on the t is simply the velocity. So this is actually the velocity of the particle at any time t. Now the second derivative, that's the acceleration, will simply be equal to the derivative of the velocity. So it will simply be derivative of 1 plus 2 cos 2ti minus 2 sine 2tj respect to time. So if we do that, we are going to have, remember the derivative of 1 is a constant, that's 0. So we're going to have minus 4 sine 2t, because when we differentiate 2t, we're going to have 2. So and 2 multiplies with this 2, we're going to have 4. And when we differentiate cos, we have sine. Perfect. Then same thing here, when we differentiate sine, we're going to have cos. And these 2 multiply with these 2, we're going to have minus 4 cos 2t in the j direction. So that's actually the acceleration of the particle at any time t. Now when t equals to pi on 4, that means that anywhere we see t, we're going to replace with pi on 4. We're going to have the acceleration of the particle v equals to minus 4 sine 2 times pi on 4 minus 2 cos 2 times pi on 4 the j direction. From there, we're going to have, we just simplify this angle. I'm going to have minus 2 sine pi on 2 because this 2 will cancel this 4 two times. Same minus 2 cos pi on 4, same thing here. Now we know that sine pi on 2, sorry, cos pi on 2. We know that sine pi on 2 is actually sine 90 degree. And sine 90 degree is actually 1. So you can take a calculator and point sine 90 degree is actually 1. See, so we are going to have, and here cos 90 degree is 0. So that's why the j component won't exist. So the acceleration of the particle will simply be minus 4 meter per second squared in the I direction. That's the acceleration of the particle. So it simply means that it means that the particle is actually decelerating. That is why the acceleration is negative. Yes. Now B, we have to look for the magnitude of the force acting on P. We know very well from Newton's second law that the force is equal to the mass times the acceleration. So since the mass is a constant, so the only variable that is changing here is the acceleration. So the magnitude of the force will simply be the magnitude of the it will simply be the man it will simply be the mass times the magnitude of the acceleration. And the magnitude of the acceleration will simply be the magnitude of minus 4 meter per second squared. That's 4 meter per second. Remember, the magnitude of a negative number will always be a positive number. So in that case, we're going to have 0 times 4 because remember the mass of the particle was given to be 0 kilogram. Yeah, that's the 0 kilogram. So we're going to have the force to be 0 times 4, that's 12 Newton. So the C part, we're equally asked to look for the magnitude of the momentum of the particle. Okay, now we know that momentum is equal to mass times velocity. See, the mass is constant, so it's not going to change anything. So we are now going to look for the velocity when t equals to pi on 2. Remember, this is our velocity that we had after differentiating the displacement. 1 plus 2 equals 2ti minus 2 sine 2tj meter per second. This is actually what we had. So when t equals pi on 4, we're going to have, we simply replace t with pi on 4 here. We're going to have 1 plus 2 equals 2 times pi on 4 minus 2 sine 2 times pi on 4 j. There's a j here. Okay, meter per second. So when we simplify, we have 1 plus 2 equals pi on 4i minus 2 sine pi on 4j. Once in the j direction. Okay, we all know that the cos of pi on 2 cos pi on 2 will actually be 0 and sine pi on 2 will always be 1. So we're going to have 1, that's I, minus 2 minus 2j meter per second. That's actually the velocity at time t. Now we need the magnitude of the velocity. So the magnitude of the velocity will simply be the modulus of this as square root of I, or the coefficient of I here, that's 1 squared, plus the coefficient of j, that's minus 2 squared. And if you do that, we're going to have exactly 5. So the velocity or the speed will simply be 5 meter per second because actually the magnitude of the velocity gives the speed. So the speed will be 5 meter per second. So it will mean that the momentum of P will be equals to, as the amount of the momentum will be equals to the rate of 5 kilogram meter per second. Okay, now let me just explain something. Otherwise, another student could still decide, instead of taking the magnitude of the speed, he could rather decide and multiply this velocity directly with by theory, then before taking the magnitude. Yes, and he or she will have the same answer. So you can go further and do that without any problem. So mean that you multiply the velocity by theory, since the mass is theory, then before taking the magnitude of the momentum. Hope it's clear. Okay, so our momentum was found to be 3.5 kilogram meter per second. Now we are asked to look for the velocity of P relative to Q when T equals to pi on 4. Okay, we know very well that the velocity of P relative to Q is given by Vp minus Vq. That is the velocity of P minus the velocity of Q. We know the velocity of P or the particle P. The velocity of the particle P is what we found here after differentiating. Is here is the velocity of the particle P. And at time t equals to pi on 2, when we replace, this was actually the velocity when we replace. So this is actually the velocity of P. Also, the velocity of Q, this is the velocity of Q minus I plus 2j meter per second. Okay. So if you make the difference between those two, Vp will be equals to this in the column form 1 negative 2 and Vq negative 1 2 like I showed you earlier. So the velocity of P relative to Q will simply be 1 negative 2 minus negative 1 and 2. And when you take 1 minus negative 1, you're going to have 2, and minus 2 minus 2 will be equals minus 4. So actually the velocity of P relative to Q will simply be 2I minus 2J meter per second. Okay guys, thank you guys for watching, and what I can note here is that the most difficult part is not actually to subtract, because we all know how to subtract. The most tedious part here is to know that the velocity of P relative to Q will always be the velocity of P minus the velocity of Q. So you have to take note of that.